An aqueous solution is a solution in which the solvent is water. It is usually shown in chemical equations by appending to the relevant chemical formula. For example, a solution of table salt, or sodium chloride, in water would be represented as NaCl. The word aqueous means pertaining to, related to, similar to, or dissolved in water. As water is an excellent solvent and is also naturally abundant, it is a ubiquitous solvent in chemistry. Substances that are hydrophobic often do not dissolve well in water, whereas those that are hydrophilic do. An example of a hydrophilic substance is sodium chloride. Acids and bases are aqueous solutions, as part of their Arrhenius definitions. The ability of a substance to dissolve in water is determined by whether the substance can match or exceed the strong attractive forces that water molecules generate between themselves. If the substance lacks the ability to dissolve in water, the molecules form a precipitate. Reactions in aqueous solutions are usually metathesis reactions. Metathesis reactions are another term for double displacement, that is, when a cation displaces to form an ionic bond with the other anion. The cation bonded with the latter anion will dissociate and bond with the other anion. Aqueous solutions that conduct electric current efficiently contain strong electrolytes, while ones that conduct poorly are considered to have weak electrolytes. Those strong electrolytes are substances that are completely ionized in water, whereas the weak electrolytes exhibit only a small degree of ionization in water. Non-electrolytes are substances that dissolve in water yet maintain their molecular integrity. Examples include sugar, urea, glycerol, and methylsulfonyl-methane. When writing the equations of aqueous reactions, it is essential to determine the precipitate. To determine the precipitate, one must consult a chart of solubility. Soluble compounds are aqueous, while insoluble compounds are the precipitate. Remember that there may not always be a precipitate. When performing calculations regarding the reacting of one or more aqueous solutions, in general one must know the concentration, or molarity, of the aqueous solutions. Solution concentration is given in terms of the form of the solute prior to it dissolving.